Here are the answers for the homework, section 4-3, page 132, number 1. We're going to factor this using prime numbers. We want to find all the prime numbers that multiply together to make 128. A systematic way to approach this is to divide 128 by the first prime number, which is the number 2. So 128 divided by 2 makes 64. 128 is equal to 2 times 64. Now let's take 64 and divide it by 2. This would allow us to rewrite this as 2 times 64 divided by 2 is 32. So 2 times 32. Notice I'm replacing 64 with 2 times 32. Let's follow this same technique. 2 times 2. Now, what can we replace 32 with? 32 divided by 2 is 16. So this is 2 times 16. Let's extend this technique. 2 times 2 times 2 times 2 times 8. And let's keep going. I'm going to continue up here into this space to do this. We have 2 times 2 times 2 times 2. And now let's factor the 8 as 2 times 4. One more time. We have 2 times 2 times 2 times 2 times 2. And now let's factor the 4 as 2 times 2. There are no more prime numbers that we can use to write this out. So our answer for 128 is 2 to the 7th power. We have written 128 using a prime number, the number 2, and the exponent indicates how many times that prime number is multiplied to itself. For number 3, we have the number 630. We can use that same systematic technique. Let's rewrite 630 as 2 times 315. Now let's try to factor 315. It will not divide by 2 because 315 is not an even number, but I notice it ends in 5, so I know it divides by 5. So we can write 2 times, and now let's go 315 divided by 5. That makes 63. So 5 times 63 can be substituted for 315. Now let's factor 63. We have our 2 times our 5. Let's think of 2 factors of 63. How about 7 times 9? Now let's factor the 9. We have 2 times 5 times 7 times 3 times 3. Every number in this list is a prime number, so this is our prime factorization. 2 times 3 to the 2nd power times 5 times 7. You'll notice I'm writing them in increasing order, and I'm using an exponent to indicate we had a multiple number of 3's. Now the number 53. Let's try to divide it by the first prime number 2, but it doesn't end in an even, so it will not divide by 2. Let's try to divide by the next prime number 3, but 53 does not divide by 3 either. The next prime number is 5. It won't divide by that. The next prime number is 7. It will not divide by that. And we would try 11 and 13 and so on. We'll find out that 53 does not divide by any prime numbers. So it is already prime. Number 7, the number 5096. Let's think of 2 factors that multiply together to make 5096. 5096 is an even number, so we know for sure it divides by 2. This could be written as 2 times 2548. That number is an even number, so we know for sure it divides by 2. We can write it as 2 times 1274. That's an even number, so it'll divide by 2. 2 times 2 times 2 times 6, 37. There's no point in trying to divide by 2 again because this is not an even number. The next prime number to try dividing by is the number 3. But 637 will not divide by 3 because the sum of the digits does not divide by 3. The next prime number is the number 5, but that will not divide by 5. It doesn't end in a 0 or 5. The next prime number is the number 7. Let's try 637 divided by 7 on a calculator. That makes 91. So in our next step, we have 2 times 2 times 2 times 7 times 91. Does 91 divide by any prime numbers, or is 91 itself prime? Maybe 7 works again. Let's try 91 divided by 7. That makes 13. So we can write 91 as 7 times 13. 13 is a prime number, so we're done. Our prime factorization is 2 to the third power times 7 to the second power times 13. This product is equal to 5,096, and it uses only prime numbers in the product. Number 9 has two parts. Part A, we're going to find the greatest common factor. Part B, the least common multiple. The greatest common factor means let's find the greatest factor that's common to both numbers. Let's find the largest number that divides into both numbers. Maybe you can tell right away that the number's 25 because both numbers will divide by 25. But if you need a systematic way to do this, we can write the prime factorization. Let's rewrite 125 as 5 times 25, and then rewrite that as 5 times 5 times 5. For the number 75, let's rewrite it as 3 times 25, and then write that as 3 times 5 times 5. To find the greatest common factor, let's look for common factors. 125 has a factor of 5. Does 75? Yes, it does. I'm going to circle a 5 from here and a 5 from here. 125 has another factor of 5. Does 75? Yes, it does. I'm going to circle another common factor of 5. 125 has another factor of 5. Does 75 have any more factors of 5? No, it doesn't. 75 has a factor of 3. Does 125? No, it doesn't. So the common factors for both numbers are 2 5s. Having common factors of 5 times 5 means the GCF is 25. In question B, let's find the least common multiple. Multiples of 125 are 125, 250, 375, and so on. Multiples of 75 are 75, 150, 225, 300, and so on. What is the least one that's common? We can use our prime factorizations to help us find this. Our least common multiple must use every factor from our first number. So let's write 3 5s multiplied together. Now look at the second number. If we already know the least common multiple involves 3 5s, then that would already include these 2 5s. The other factor of 75 is the number 3. Let's use that when creating our least common multiple. So our least common multiple can be found by multiplying 5 times 5 times 5 times 3. This is 125 times 3, which is 375. This is a multiple of 125. It is 125 times 3. And it is a multiple of 75. This is 75 times 5. Number 11. Let's find the prime factorizations to help us to get the GCF and LCM. The number negative 90 is equivalent to negative 1 times 90. In turn, this is equivalent to negative 1 times 2 times 45. This is equivalent to negative 1 times 2 times 5 times 9. And this is equivalent to negative 1 times 2 times 3 times 3 times 5, where the 3 times 3 is replacing the 9. For the number 225, we can write 5 times 45. This is equivalent to 5 times 5 times 9. And this is equivalent to 3 times 3 times 5 times 5, where the 3 times 3 is replacing the 9. Let's do question A and get our greatest common factor. Is -1 a factor of both numbers? No, it's not. Is 2 a factor of both numbers? No, it's not. How about 3? 3 is a factor here, and 3 is a factor here. So our greatest common factor will involve the factor 3. What about this 3? Does the other number have another 3? Yes, it does. So our greatest common factor will have another factor of 3. What about 5? There's a 5 here, and there's a 5 over here. So our greatest common factor will have a factor of 5. 3 times 3 is 9, times 5 is 45. 45 is the largest factor of -90 and of 225. Now let's do question B and get our least common multiple. By definition, least common multiples are positive numbers. So when we look at the factors in our prime factorizations, we can ignore the -1 factor. The first number has 2 as a factor, so our least common multiple must have that as a factor. The next factor is 3, so our LCM must have a 3. The next factor is another 3. Let's put another 3 in our LCM. And the next factor is 5. Let's put a 5 in our LCM. Now go to the other prime factorization and see if there are any factors we haven't already written down. We've already written a 3, we've already written another 3, and we've already written a 5. But we don't yet have a second 5. So let's put that in our LCM. Now multiply these factors together to see what number this is. This makes 450. Number 13. The numerical coefficient 2 is already a prime number, so we don't need to factor it further. We can, however, expand out the meaning of x squared to create this expression. In our second number, the number 10 can be factored as 2 times 5, and we can expand out the meaning of y squared to create this expression. Now let's do question A and get our greatest common factor. Both numbers have a factor of 2, so that's common. However, only the second number has a factor of 5. It is not common to both. Both numbers have a factor of x, so let's put an x in our GCF. This one has another factor of x, but the other doesn't, so that is not common to both. And both numbers have a factor of y. Let's put a y in our GCF. Multiplying these together, we get 2xy. Now let's do question B and get our least common multiple. It must have a factor of 2. And it must have a pair of x's. And it must have a y. Now let's go to the second number and see if there are any factors that we haven't yet written. We've already written the 2, but we haven't yet included the 5. We've already written an x, but we've only written one y so far, and this one has 2 y's. So in our LCM, we need an exponent to indicate 2 y's. Let's multiply these together to get the answer. 10 x squared y squared. Number 15. We can rewrite this number as -1 times 2 times 2 times r times s times s. The other one can be written as -1 times 2 times 3 times r times r times r times s. From these expansions, we can get our GCF and our LCM. By definition, greatest common factors are positive numbers, so we can ignore the -1 factor. There is a 2 common to both of them. Let's put a 2 in our GCF. This number has another 2 as a factor, but the other doesn't, so it is not common to both. There is an R in both of them. The second number has more R's, but the first does not, so that's not common to both. There is an S common to both numbers. The first number has another S, but the other one doesn't, so that's not common to both. Multiplying these together, we have 2RS. Question B, the least common multiple. Again, least common multiples are defined to be positive numbers, so ignore the -1 factor. We need to have a factor of 2. We need another factor of 2. We need a factor of R. And we need 2 S's. That uses up all the factors of our first number. Now let's look at the other number to see if we need to put more factors. We've already put a 2 in our LCM. We haven't yet put a 3. We've already put an R in our LCM, but we haven't put another pair of R's. And we've already put an S in our LCM. Let's multiply this together. 2 times 2 times 3 makes 12, and we have R to the third power and S to the second power. Number 21, list all integral factors of 28 except 28 itself. So all numbers that divide into 28. 1 divides into 28, 2 divides into 28, 4 divides into 28, 7 does, and 14. Then it says, show that these add up to 28. 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 7 is 14, and 14 plus 14 is 28. For the review assignment, we're going to page 129, the orals, and we're asked to multiply these binomials together. The technique that we've been using is called FOIL, which is another name for the distributive property if you have a binomial times a binomial. N times n is n squared. Our outer product is n times -2, which is -2n. Our inner product is -1 times n, which is -n. And L means last, -1 times -1, which is +2. Now combine the n terms together. Number 16, let's use FOIL again. T times t is t squared. Now the outer product, t times 2, is +2t. And the inner product is -3t. And then last, -3 times 2 is -6. Now combine the t terms together. Number 20, let's use FOIL. X times x is x squared. Now our outer terms, x times 3y, that makes +3xy. Now the inner terms, 2y times x, that makes +2xy. And the last, 2y times 3y, that makes +6y squared. Now let's combine the xy terms. For page 129 written, let's continue to multiply polynomials. This first one fits the pattern where you use FOIL. A squared times a squared is a to the 4th power. Now the outer product is -5a squared. And the inner product is -2a squared. And the last, -2 times -5 is +10. Now combine those like terms. For problem 12, we have a binomial and we're asked to square it. Squaring a binomial means multiplying the binomial to itself. So this expression is equivalent to this one. Now we can use FOIL. X to the 3a times x to the 3a is x to the 6a. Remember, when you multiply variables, you add the exponents. 3a plus 3a is 6a. Now the outer product. That's negative 3 x to the 3a. Now the inner product. Another negative 3 x to the 3a. And the last, negative 3 times negative 3 is positive 9. Now combine these two like terms. Number 24 is a binomial times a binomial, so it's FOIL again. R squared times r is r to the third power. Now the outer product, we get negative r squared s. Now the inner product, we get positive r s squared. And now the last, s squared times negative s is negative s cubed. This time we don't have like terms because r squared s is not the same thing as rs squared. On page 126, we have to multiply some monomials together. Start with the numerical coefficients, 4 times 5. That makes 20. Now multiply the variables. N to the third times n to the 1 is n to the fourth. Number 10. This has multiplication here in the middle, but it also has a product raised to an exponent. Exponents is done before multiplying. So we first have to distribute that power to all of the factors inside the parentheses before we do anything with the 5ab. So let's rewrite this question. Here's the 5ab. It stays out at the beginning. Now let's rewrite this piece of the problem. Negative 2 to the third power is negative 8. A squared to the third power is a to the sixth power. And b to the third power is b to the third. Now we can do our multiplying. 5 times negative 8 is negative 40. A to the 1 times a to the 6 is a to the 7. B to the 1 times b to the 3 is b to the fourth. Number 14 is a division problem. Let's start with our numerical coefficients. Negative 15 divided by 5 makes a 3. Now the variables. R to the fourth divided by r to the fourth cancels away. Another way to think of that is subtracting the exponents. 4 minus 4 makes a 0, but r to the 0 is just equal to a 1. Now let's look at the letter C. We have c to the third power. We're dividing by c to the first power. The single c in the bottom cancels away one of these, leaving two of them remaining. Another way to think of that is by subtracting the exponents. 3 minus 1 leaves an exponent of 2. Our answer is 3c squared, and there's really not anything in the bottom other than a 1, so we should write this as 3c squared. Number 20, we have division again, but we also have a power on the outside. Let's do the division inside the grouping symbol to make this as nice as we can, and then raise to the power. Start with the numerical numbers, the 18 and the 27. They both divide by 9. 18 divided by 9 is 2, and 27 divided by 9 is 3. So 18 over 27 reduces to 2 over 3. Now let's look at the letter D. D to the fourth divided by D to the third. If you subtract the exponents, you get D to the 1. Another way to think of this is that the 3 D's in the bottom will cancel 3 of those away, leaving just 1 left over. Now look at the letter H. Let's subtract the exponents. 6 subtract 5 is 1. So there's an H to the 1 left in the bottom. Another way to think of that is all 5 of those H's will cancel 5 of those away, leaving 1 of them left in the bottom. So inside the parentheses, it has reduced to this. And on the outside of the parentheses, there is still squaring. Now let's square every factor in those parentheses. 2 squared is 4. Then D squared. In the denominator, 3 squared is 9. Then H squared. Number 26. We have a pretty complicated problem and we need to put it in simplest form. So let's follow our various exponent rules and pay attention to order of operations. There's multiplication here, but before we can multiply these, we have to do this exponent because exponents comes before multiply. So 2 squared makes 4, and then x squared. Let's rewrite the negative 3x. Then we can multiply these together. This is negative 12x cubed. Following this is this subtraction sign. Now let's pay attention to this area of the problem. 9 divided by 9 reduces to just a 1. Some people call that cancels away. Look at this section here. There's also some canceling. The binomial in the top matches the binomial in the bottom. This one cancels away one of these, leaving 1 left over. And so this middle section of the problem just creates x cubed plus y cubed. Now let's focus over here. Before we can multiply the y, we have to do that exponent. So we have y times negative 5 squared makes 25, and y to the second power is y squared. Timesing these together, we get 25y cubed. Let's look for like terms. Negative 12x cubed subtract 1x cubed. That makes negative 13x cubed. Then we have negative y cubed plus 25y cubed. That makes positive 24y cubed.